Okay, tonight I'm going to be talking about the future of space travel, and my claim is that unmanned autonomous robotic missions will replace manned missions in the near future. Currently, there is proposals for a manned mission to an asteroid in 2025 and a manned mission to Mars in 2030. I feel that robotic missions are more efficient and will therefore replace these missions sometime after that. My key points are that 1, unmanned missions are more cost efficient, they're cheaper. 2, they're safer. 3, they're more feasible due to the time it takes to travel between planets. And 4, rovers are capable of collecting completely meaningful data that humans can. And because of the 3 other subpoints, it's therefore a better choice. Okay, my first point, that unmanned missions are more cost efficient. If we look at the Apollo missions, those cost $170 billion in 2005 dollars, and that's about $28 billion per year that the missions are going on. And contrast to that, the Albatross, which is the moon bombing that happened in fall, that cost $79 million. The rovers that are currently on Mars and have been for 4 years cost a little over $1 billion. That's all these numbers are from NASA, and that's a little over $170 million per year. So both of these combined are cheaper than the Apollo missions. And that brings me to my second point, that unmanned missions are safer. It's obvious that if you're not sending somebody up to space, they're not going to die. But when you do send people, like in Apollo 1, that crashed and ended up killing people. Challenger, as we all know, that's the famous one, and the recent Columbia disaster in 2003. Third point is that it takes time to travel between planets. And when you have a rover, you don't have to worry about feeding it or even a return trip back. Currently, the current space shuttle, according to NASA's website, travels at 17,000 miles per hour in orbit. During the closest orbit Mars comes to Earth, it would take 81 days to reach Mars, but at the farthest orbit, it would take 610 days. And when you have to take into account you have to make a round trip, and you're not going to catch the smallest orbit both times, it really makes it not very feasible to try and send humans there when you can send a rover and only have to make one-way trips. And you don't even have to worry about launching extra weight with food, which takes a lot more rocket fuel. And then my fourth point is that rovers can collect meaningful data as efficiently as humans. Spirit and Opportunity have found evidence of water on Mars. They're continuing to go, and they're continuing to find out new things about the surface of Mars. And then Carnegie Mellon, their Robotics Institute, has been working on a project called Life in the Atacama, which is, the Atacama Desert is in South America. It's the driest, most inhospitable place on Earth, and there's virtually no life. The purpose of the Life in the Atacama project is to create a semi-autonomous robot that will search on its own, find its own path, be able to power its way through the desert, and then recognize where to stop and take readings, and then be able to find the actual evidence of life. Recently, they've been able to very efficiently get a robot called Zoe to travel through the Atacama, stop, use a fluorescent imager, and find evidence of lichens, which is a form of life. And then there's a future proposal called the Ares project, which is proposed by Joel Levine from NASA. This is basically an autonomous plane that will fly across the surface of Mars where the rovers currently can't go because the terrain is too rough. And this plane will measure magnetic fields and search for possible landing spots to send more rovers that would be more efficiently finding evidence of life. And in conclusion, it is more efficient to send robotic rovers out to deep space because they're safer. You don't have to worry about extra fuel and wait for food when you're sending them. You can just send a rover off into space and monitor it and then pick up right when it lands. It costs a lot less money, and you can get the same meaningful data. Thank you.
All right, the propositions clearly stated, the secondary claims were laid out for us adequately. I'm not sure that retrieval of data and productivity of the information is the thing that's controversial on this particular issue. Is there a need for human missions? I think there should be some discussion of that, and maybe that should be the focus instead of a prediction, because the truth of the matter is I'm not sure that there is much to predict. You kind of ignore a couple of the key points here that show why manned missions will actually be replaced by the robotic missions that you're talking about. One is that the one program that was planned for exploration of space by mankind has been, by humans I should say, has been abandoned by the president. That's the Constellation program, and the other is the end of the space shuttle without a replacement. So the likelihood of frequent missions into outer space with at least American astronauts is relatively small. So we are going to have to rely on those things. I think that's a stronger argument to make than the notion that, well, we've got some of these robots that can do this other kind of stuff. That's probably true, and I don't think there's any dispute about that. The big controversy is whether or not we need human beings on those missions, and I think that you do okay when it comes to collecting the data, but again, I don't know that data collection is the thing that's controversial on this. The whole argument about risks, for instance, I think is a little problematic when you mention the Apollo, the Challenger, and the Columbia, because none of them would be examples of missions like you were talking about. They are man-based missions. The Challenger and the Columbia missions, for instance, are to near space, not further out in space, so the risk factor is there. And I'm not sure, for instance, on the Columbia, that any of those missions could have been replaced by robotic things, because that mission was taking place on the International Space Station, and a lot of it's about life stuff that's going on up there. They're doing experimentation on mice and rats and cockroaches and plants and human activity and that kind of stuff. That's the kind of stuff that you need to show we don't need to have that, it doesn't get us anything, or that we can do that in simulated situations on the planet. I think that's, like, again, where the controversy is on the point. But there's not much dispute on some of the issues, and you presented pretty good data on those points. I think you're a little casual in the presentation, and your argument, I think, is much more applicable to the Mars mission. I think that that's a good place that maybe you could focus on a little bit more. Maybe that should be the way the argument is phrased. All right. Thank you.